Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hasif bin Muhammad Anwar. My metric number is DE180113. So for today, I will present about lab activity 1 for lab sheet 5 of Kill Microvision. So this is the first lab activity 1 that we are needed to compile the particular given program and need to debug it. So this is the layout after I had debugged the coding and compiled it. After that, we are needed to go to peripheral and click to AD converter like this. And as we can see here, we are needed to set the data from 0 volt until 3.3 volt. So I will show 3 results that are started from 0 volt. So let's take a look for the result we got. And we start with 0 volt. This is the layout we got. And let's tick the PDN, burst, age, dime, and the overrun. You also can tick on the ADIN PEN 0 until 7, but in this case, we are just needed to generate the data, the result for analog input 0, AIN 0. So this is the layout for our result of AIN 0 analog input. We got the AG global data and status is 0 of 400,000, and this is the result we got. And we move to the next one. We will take the between 0 and 3.3, 1.65 volts. So let's take a look. What I'm just going to get at the AD channel data. So result, the answer is 1.65 of panel input, and the result will be like this layout. And another one is 3.3 volt. And let's take a look where we got the answer. It's correct or not. So the answer is 0 times of 800,000, 8 million. So this is the result for lab activity 1. We are needed to modify the coding so that we got the result for ADNO2, ADO.2 of the ADC. So let's check it out where we can modify it with, and stop the debug section again. And we got this layout. All is okay. Then we need to check the peripheral and AD converter. So this is our layout. 0.0. So for this case, we are needed to get the annual input of AIN2 because we are asked to modify the coding to get the result of ADO2, ADO.2. So let's take a look. At 0, we got this layout and we change it to 1.65 and we got this one. The result is like this. You can start it. Now P2.1, P1.27, MAT 0.1, MAT 0.3, MAT 1.0, MAT 1.1. So this is the layout we got after we modify the result. And then, so those are the result after we modify. This is the last result of 3.3 volt. So that's all for lab activity 1. Thank you.
Assalamualaikum and hi. My name is Muhammad Kamiti Muhammad Yassin. Magic number DE186016. For my part, I will do for activity 2, which is to run and debug the C programming for LPC 1768 microcontroller by using LPC 1768 microcontroller. So this is the coding that I have derived by moving the R1. So from here, I click on the option for target. So click on the debug. So rename the dialog DLL, which is radrmp1.dll, and add parameter. Rename dash PLPC 1768 and click on OK. And after that, build the program. After build the program, click on the debug season. So we can see the windows that are using the LPC 1768 system. So this is the system from the coding that I have derived. This is the output. So from here, register, try to move the R0 until to R15. So this window is to identify the step from the instruction that I have derived at the C programming. So from here, also this is the disassemble that recognize the system from my coding also, that have to identify where the coding are moving. So if I click on the stat from 0, this is also move at the clock setup. So this is we're starting from the also from before the clock setup. So this is also from 0. So when I click on the setup again, we are moving. This also we're moving. So from here, the windows we can see until, if I click on the setup, it will move until the end, until the R15. So this is all for me. I will pass to the next presenter. Thank you.
Assalamualaikum. I'm Hedri Adel Shahizi bin Azmira. It's number DE180138 and I'm from Group 6. So for the lab assignment 1, I would like to present about this lab assignment 1. So this is the coding for lab assignment 1. as you can see here. And this is the result what I get before we run. And after we run, we get this result for the lab assignment 1.
Hi, a very good morning to Dr. Daniel. So my name is David Tionongwei, CE190146. So for this lab, I'm doing for assignment 2 for lab 5, analog to digital and digital to analog conversion. So go to lab assignment 2. We need to write a program to create a sawtooth waveform like in this figure. So in this Kali software, I write this coding and we save the coding and build the target, and there is no error and one warning. So after that we debug this coding. After that, show the logic analysis and set up it to P2, close it and start to run, and zoom out, zoom in, and that's it. This is the case sawtooth waveform. So that's all for me. Thank you.